Welcome all to the demo session for eBus System Planning and Optimization. We are also joined by Mr. Sanjay Bhatia, who has been till recent times heading the sales and marketing team in Tata Motors, and he has also been one of our participants in the previous batch. So it is great to have you to share your experiences. We will go through quickly the deck and then I will pass it on to Sanjay to share his experiences. And we can also then take up the question and answers. Uh, So basically, this training program it has already successfully run two batches starting January this year, and the primary motivation for this program, this is one of its kind program across the world. The primary motivation has been that most of the uh, municipal bus fleets, the intra-city bus fleets across the globe, will be electrifying those fleets partially, and then successively they will go towards complete electrification of those fleets in the coming years. Yeah. However, this electrification, wherever we have seen the pilots in India as well as across the world, there have been some challenges, and most of them have been in terms of operational challenges due to either the products that were procured, both in terms of the vehicle as well as the charging solutions, where different, the performance of those products was different from what was expected or what was initially assumed. Yeah. And then the utilization of the fleets has been poor, and that has caused a high deviation from what was expected return on investment. The Despite having lower utilization, we also had instances of operators missing the SLAs, and this creates high contract risks, right, in PPP models. And then there are very specific aspects of electric vehicle, like the battery degradation, uh, which requires recapitalization sometimes if the battery life is uh, lesser than the vehicle life that has been inside the contractual agreement. And other aspects like energy consumption per kilometer of these buses being higher, and consequently the expected running per day, the daily kilometers that the bus is expected to put within the battery capacity available, which we also call as a range, has been lower than what has been uh, assumed during the planning phase. Yeah. So all of these basically contribute to a lot of risks at operational level in terms of fleet management as well as meeting the SLAs. So because of all of these observations, this program has been put together, understanding what are the training needs behind these risks and behind these challenges that the bus fleets have faced, and then combining that with what are the skills that are required to do better assessments, make more accurate assumptions while planning these e-bus deployments as well as operations. What we have in this course is basically the industry experts who have worked on these real life deployments as well as operations of e-bus fleets around the world. what are their challenge, what are the challenges they have faced on ground, and how they have mitigated these challenges uh, while the deployment and operations were ongoing, and what were the things they would have preferred to do in the planning phase itself, so that these problems do not occur during the deployment and operations. What are the things that can be front loaded during the planning phase itself, so that the expectations are set right, the decisions that are made for procurement as well as scheduling and other aspects of operations, those are done with more accurate assumption as well as more accurate data on real life running of these buses. Oftentimes, for example, the range is assumed to be what is claimed by the manufacturer, and those are actually the certification range on certification cycles or some standard cycles. And often the reality on ground for those bus applications could be different. The energy consumption per kilometer could be higher than what has been assumed. So this is just one example, but I think this is the example a lot of us correlate with the most, and not just restricted to bus usage. Right? We have seen often the range that is promised of the electric vehicles broadly has been much higher than what is achieved in realistic conditions. So what we do is we, of course, go through some of the basic principles of the planning and optimization, but we also do apply these principles that we talk about, or the solutions, or the ideas or the concepts. We immediately apply that in virtual models and assess those. So, for example, as I talked about the range and energy consumption per kilometer of these buses, we do go into energy modeling of a particular bus system for a particular duty cycle. So what we mean by duty cycle is the time versus speed that the buses would require to run in the real world, and also the loading profile, the passenger loading profiles, and the gradients, the road gradients. So these make up for primarily these are what make up for the energy that is required per kilometer of the bus. And then we also, so lot of our modeling is done in Excel. We provide some basic tools to do that modeling and perform the simulations or the calculations for different scenarios, different use cases. And then we also then bring that at fleet level. We scale those up at fleet level, analyzing multiple routes, different routes, and multiple different products, and then even get into a very broad level sizing. And once we are at the basic level, we are clear and sound on those fundamentals, we get into a more advanced tool demo, in which a lot of these assumptions are done for you, and some of the multidimensional analysis that would be too overwhelming in Excel now can be scaled up using this tool. Yeah. And this tool demo will be provided towards the end of the course, and the tool is available for usage uh, in terms of a learner's license or a basic license, free of cost for course participants for 2 months. We will have total 9 sessions, including the practical sessions. We would have 3 sessions per week. So we would have 2 sessions on weekdays, Tuesdays and Thursdays, and then we will have one practical session on Saturdays. So these are some of the on-ground challenges that we see, that I also talked about a little earlier. Rahul, would you like to take them through this?
Sure, thank you very much, Vikrant. See, there are two parts where we have seen e-bus planning becomes important. One, you have already procured the buses, right, and already doing the deployments. And most of the experience globally is like the real life experience is not matching the expected performance or the stated performance put by the OEMs, right? As Vikrant have shared, like those stated specifications are usually under lab control conditions. But when you run these buses in real life in your city cycles, then the range, which is a very important measure, is very different. This program will teach you uh, how you can estimate this thing very realistically and very closely in day one, year two, year three, and how time passes, what you can have a realistic planning of this range of your buses, and how with this learning you can really kind of improve upon your planning. Yeah. So what are the typical challenges that we have seen is like once the procurement has happened, but you see that the range is not meeting your expectations. The range deviation from the stated specification can be of the order of 50 to 100% as well. So like if 250 kilometers is what is kind of stated in specifications, then in real life with air conditioning on, with overloading of the buses, with traffic conditions and congestions in the city driving conditions, or with the high gradability going up slope, all these things can bring down the range as low as 80 to 100 also. So this have been the operational issues that we have seen. So with this course learning, you will be able to understand and diagnose those issues and bring corrections into your operational planning. So the buses are already procured. Now what to do? So once you are able to do the energy signatures, a term that me and Vikrant use, and what you will learn in this program will allow you to understand those energy signatures of the procured buses for your given city cycle conditions and be able to improve on the operations in terms of scheduling of these buses, scheduling of your chargers, and then bring the course correction in terms of driving better optimization from your existing fleets. In cases where you are yet to procure the buses, right, then this planning is very, very powerful. It allows you to kind of understand your requirements, figure out your energy signatures and use cases, and then amongst the options of the buses that are available in your country, you can choose like what bus will really meet your right conditions, right? Sometimes if you have enough time in your hand, then you can even go to the OEMs with this planning that you will learn in this program to say that, hey, I need 100 or 200 buses of this specifications doing these things, and you will also be able to command a right contract with them, a right performance warranty of the product with them, especially if you are going for a gross cost contract model, what they call typically as GCC, where the operator will pay by dollar value per kilometer or per mile. There you can leverage right contract conditions of performance year on year. So you just don't look into your performance expectations only on year one, but because there is a natural battery chemistry degradation that happens, you can account it with your planning and include it as part of the contracts. So that those are the kind of things that you can learn to really control your procurements and technical specification of the buses. You will learn like what are things you have to control from the setup and commissioning aspects. You have to have provision right space in your depot for setting up the chargers. You will understand like what are the backend substation or separate dedicated transformer requirements, and how much space, how much cost you have to provision to ensure that you have the right charging infrastructure and backend grid infrastructure. That is one of the things that we have seen gets missed in many of the plannings. and hence depot planning becomes very, very important. You will learn the aspects of like what trade-offs in terms of the battery sizing you can make in terms of your design of the vehicle, and how you can have a mix of night depot charging, which is simple, less complex, easy to manage, versus even opportunity charging. Yeah, so opportunity charging, it's little complex, right? But it allows you optimize your capex cost rightly. Yeah, but it has to be done in a right way. So those trade-offs also, which becomes important from the setup and commissioning perspective, you will learn how to bring upfront into your planning part. And at the end of day, all the performance of this already costly rebuses, if it is not met by right planning upfront, then it will lead to the performance issues which we see in many of the city buses deployments, and hence leading to ROI or contractual issues. So these are the common challenges that we have seen from procurement, from setup and commissioning, and from the operations, which you can upfront kind of understand, model and simulate, and then make sure that you are doing right things for right performance across this life cycle of the e-buses. Next, please, Vikrant. This is a very important slide. This all comes as an output and of the learning from this program that you will go through. On the left hand side, you are shown like a typical bus, which is coming with a full battery capacity of 322 kilowatt hour in the example. Vikrant, if you can show by your laser. Yeah, so on the left hand side, we have 322 kilowatt hour battery pack in a bus. Uh, and when you discount of those lower side and higher side reserves, which are not supposed to be used for healthy battery life, what we call it as a depth of discharge, that kind of taking off, then you are left with a 257 kilowatt hour battery pack, right? So this is a useful energy in your bus that is available in early year or in first year for your bus running, that is available. And this 257 kilowatt hour battery pack, again depending upon your city life cycle conditions and all usage and everything, is expected to give you close to 200 kilometers, which is the scenario one that is being showcased, right? And this scenario has been modeled when AC is off and you are running the buses in half of the occupancy, right? So this bus is will be able to give you this close to 200 kilometers under this condition. But now if you turn on the AC and still you are on your average half occupancy, then you will see that 20% of your range gets taken off just by turning on the AC. Yeah. And now if you have an overloaded condition, which is very common conditions in many of the developing or underdeveloped countries, you will see that another 20% of your range gets taken off to kind of compensate for that extra load that the bus is not taking. Yeah, and this is still in year one. So this is the kind of variations in your range just because of different load conditions and real life city conditions that an electric bus gets exposed to. And now if we take into account also the degradation which will happen because your battery is now getting exposed to different conditions of thermal cycling, city conditions, usage conditions, discharge and charge cycles, all that will also lead to deterioration. So accounting for those deterioration in some later years of your bus, then this 200 kilometers, which is the day one that you were expecting range under sun operating condition, this could actually become almost close to 100. So 50% range reduction could be happening if you really are. So this is all coming from physics and reality database modeling. So this is what you will be able to learn into the course, and much more different aspects, and be able to make the eBus projects strong. The learnings also go deep into right design of the e-buses. So if you belong to an OEM community, you will be able to appreciate the challenge faced by your consumers, which is operating these buses in real conditions, versus as an OEM, you are talking of lab conditions, right? And there are still learning curves. Even most of the OEMs will appreciate they also have in this new technology. And with that appreciation, you will be able to go deep into realistic performance modeling and simulations, and that will allow you to go deep into your subsystems and overall vehicle integration improvements and upfront modeling and simulations. Next, please. This is another kind of modeling based results where you can have different routes. So same bus running on three different routes. Yeah, the first one is a small route, short route, which is a kind of typical of the urban cities where there is heavy congestion. The bus will move at low speed, and there will be frequent on-off conditions. And here with AC on and AC off conditions, you see that that same bus, which was giving 200 kilometers under normal conditions, already brings down to 120 and 152 kilometers per full charge. Yeah, so that is that one route condition in which you are able to model and simulate your bus performance. Now, if the same bus you take to the other extreme, if it is running on the right side R3 route, which is a long route, let's say assume it's running a shuttle bus, same bus service, basically running between airport to the city, and there are less stop events, and it is able to drive at faster conditions, then the range that it can bring with the same conditions is almost between 158, 160 to 200 kilometers. So a same bus operating in two different routes, if you are using the mixed route conditions, can give you a range which is varying from 120 to 200 kilometers. So once you are aware of these situations, then you are able to really put a right application to this bus and do a right level of planning. And this is a slide. We have borrowed it from our partners, Microgrid Lab, who actually designs software tools for doing the eBus modeling and simulations. So it kind of brings about all the different parameters and interdependencies that exist for eBus planning. It is much more complex, and the sensitivity to the end output is quite high when you compare to the IC. So from the product complexity, eBus is a simpler because it has less moving parts, so robustness is good. But when you have to deploy, and because of the range sensitivity to different conditions, the planning aspect of it becomes much higher order complexity. So in this course, we we will teach you to use some tools, but these are all open source Excel based tools, so that you also learn the fundamentals of this tool and you are able to expand for your specific application. Grant, can you take this up, please?
Sure, sure, yeah. So this is the overall session coverage. So going from the basics of eBus system and the planning aspects, we'll go through the energy modeling. That is the sequence with which I mean you saw a few slides earlier, which is the one of the systematic approaches to the eBus pre-planning. So we'll go through the first the energy modeling. Using this energy modeling, we will go through different routes and their energy signatures, and then look for what is the kind of energy required on board, which is essentially the battery size, and also what are the routes, in what mix, and at what frequency can be deployed. Um, Looking at also the charging time requirements. Yeah. And then going from there into the charging strategies, whether overnight full charging is adequate, or there is a need for opportunity chargings. Even the overnight charging, which way it is to be done, whether there would be one charger per bus and slow charging, or you would have fast chargers with either automatic switch over to the next bus, or manual switchovers, and so on. Yeah, it will also depend on what kind of electricity tariff regime is in the region, whether it is demand based, or it is consumption based, or it is a hybrid of the two. Yeah? Or all three are possible. We will also have these practical sessions in which, for example, session 2, we will discuss how the bus energy can be modeled, the energy consumption can be modeled. And in session 3, which is a practical session, we will actually do it all ourselves using the Excel calculation tool. Then moving on to again, the session 6 is going to be a practical session where we will apply what we learned in session 4 and 5 onto the same or similar Excel tools, and trying to make sense out of real life scenarios, how we can schedule and how we can make space for charging or account the charging time, and also decide upon what would be the charging strategy that is most likely will be used. Then we will go through various e-fleet performance scenarios and optimization, including the mixed fleet usage, and then also going through real life disruptions or deviations that we see to the base plan. So base plan is usually done with certain redundancies. In session 7, we will see how those are, how to understand whether those are adequate, or there is something else that has to be built into, some redundancy has to be built into the plan to cater to these disruptions. Then we will go through total cost of ownership analysis using different costs, capex and opex elements over the life cycle, and then impact of battery aging on the SLAs, as well as how to incorporate battery aging and replacement into the TCO analysis. And then finally, we will go through the entire analysis that we have done up to session 8 in terms of a practical, where we will incorporate all of these things with the perspective of the cost analysis. So doing the TCO for the case study that we have built over the session 3 and session 6 practicals, as well as what we have discussed in session 7 and 8, applying those into creating a scenario with a disruption, with one or more disruptions, and then performing the total cost of ownership analysis. This course is particularly beneficial for, of course, the state transport undertakings, the public transport authorities, as well as private operators. It is also important for policymakers to understand the ground challenges, the ground level challenges, before finalizing the policies that will affect the operations, as well as the overall cost of operations, or the overall cost of deploying these fleets. And then professionals and consultants who are into uh, uh, analyzing and putting out these studies around the feasibilities, around the targets for electrification of the e-bus fleets across the country or the globe. It will also benefit students and academicians who are into transport planning, who are into the optimization of these deployments. A lot of students take up case studies for real life scenarios and the deployment of those, and then come up with the challenges. So this is an opportunity for them to build upon those case studies that they have already performed, and then assess them through these analytical tools, and understand how to root cause these challenges and how to possibly resolve them. This also is useful for the e-bus manufacturers, primarily because it also talks about what are the use cases for which these e-buses have to be designed for, but also because a lot of OEMs in these pilot phases, as well as probably in future, would also be acting as service providers, not just selling the vehicles, but also providing the operational services, or at least the vehicles as a service, including its maintenance and end of life recycling of batteries and other systems. It will also benefit researchers and think tanks to assess these proposals of pilot studies as well as deployments in a more accurate fashion. And it will also help multilaterals and funding agencies to understand the real feasibility and return on investment of those investments and fundings. So these are some of the examples of route energy consumption models that we will be doing. Different routes, different characteristics. Some routes would be repetitive in terms of stop and go traffic, and then intermittent running on suburban roads, which would have lesser traffic or maybe faster moving traffics and so on. So different scenarios and different aspects will be covered. Also, we will talk about how the terrain affects the energy consumption. You can see a sample graph on the right hand bottom corner, where we have compared examples of flat terrain versus slightly hilly terrain. And it could go even more, like if we have extremely hilly terrain, this keeps growing, the energy requirement keeps growing. Then, as I said, we will talk about battery sizing and possible standardization across routes. If it is there is a potential to standardize the battery size across all routes, it is a very good scenario. You do not have different variants in terms of battery capacity of the bus, and it is less complexity to be managed. There is also possibility of swapping buses across routes, interchangeability. It also helps you reduce the investment in terms of redundancies that have to be built in. So we will talk about all those aspects. How the battery sizing is done, what parameter of the battery affects what aspect of the electric vehicle performance, as well as integration. And then how to actually try out different uh, uh, combinations. However, this is more of the premise of the OEMs, but it is useful for the operations folks to know these, so that when they are selecting a particular product, they would make right choices based on the available variants and products in the market. Then we will also talk about charging scenarios, how different charging strategies can affect the operations, the schedule, as well as the risks, how they would crop up in different strategies. We will also talk about how to evaluate each of these scenarios over the schedule of the particular route, as well as the overall fleet. and how it affects the power demand as well as the energy demand. Then going into the total cost of ownership, again, we have these tools available which will be provided to you as the basic calculation tool, which you can build upon further and also do all of your sample analysis. And you can see how certain parameters have higher sensitivity as compared to other parameters, and which are the things, which are the levers that you have to try out the different scenarios and optimize on total cost of ownership. So these are this is a summary of the brief. This is a brief summary of the outcomes of this course. Sorry, it provides you a holistic learning of sorry, planning and optimization of e-bus fleets, how the battery and the charging systems work, what there are often nuances of these charging systems where we assume a certain charging time based on the kilowatt of the charger and kilowatt hour of the battery. However, oftentimes the charging doesn't happen that way. There are phases in the charging which we learn, the constant current and the constant voltage phases, which mean that it is not a direct arithmetic based on the charger kilowatt and the battery capacity, but it is slightly higher than that. And how to estimate that? Then route network and planning considerations. We will also talk about how to optimize the performance parameters. So oftentimes the overriding performance parameter that we talk about is the battery capacity or the range the bus can provide. However, the performance in terms of, especially in hilly terrains, the performance of the motor in terms of its peak power and its capability to negotiate that hilly terrain is also of importance. Otherwise, those routes cannot actually be catered to by electric buses. So bringing all the routes into the purview of electric buses requires the performance analysis in terms of the applicability to hilly terrains and other aspects of performance. We will also learn how the route characteristics impact the bus performance. We will also learn how ambient conditions and different passenger loading will impact the bus performance, and we have to plan for those. Then optimizing on the fleet as well as charging. So whether the bus can share chargers, what would be the mode of interchanging the charger guns to different buses who are sharing the chargers, how we can schedule those buses who are sharing the chargers so that we can maximize charger utilization. And then finally, all of that will help us optimize both the capex and the opex, which will result in lower per kilometer costs.
Grant, we
Yeah.
may suggest that Sanjay kind of share his experience.
Yeah. So I think before going into the rest of the structure of the program, it would be great if Sanjay, you can share your experience in this training program.
Yes, good evening. Good evening once again. So,
Good evening.
yeah, I had attended this program, last program, and it was really a good experience, even though I had come from Tata Motors and we had been successful in getting very big contracts. But still, when I came out of Tata Motors, I thought maybe let me understand and see what is there outside the OEMs. So it was a very good experience going through this some 8 9 sessions which were there, and it actually gives a very good overall view of the EV bus. Since this is a new technology, I mean this knowledge is not available in the market, and there are very few training programs. In fact, I am really not aware of any such program which gives the overall picture of EV bus, starting from basics of the vehicle and getting into operations, different type of technologies which are there. And another good thing about the program was the international experience. So people talking about what all they had faced when they operated these buses in different conditions, and how what all people operating in India can learn from their experience. So this is a very good overall package, which actually gives you very good basics about the whole EV. And there are a lot of people who want to actually come into the EV because this is a new technology, new field for everyone. And since the country is going through a new phase wherein the old things are being dropped and new things are being taken out, I think P Manifold is doing a very good job in trying to train and give a very good knowledge base. So they have, I really appreciate and I enjoyed all these 9 sessions which I had. And end of the day, it's a very good experience. Thank you.
Sanjay, if you can also share some of your experience in terms of the teaching style, because we keep hearing these questions, and I'm already seeing some questions like what is the level of time commitment required? Because we are really focusing on skills. So yes, there is some work and time required, but how does it really pay off to really learn those excels from those fundamentals and be able to model it yourself? So if you can also share some of that experience of doing the assignments, doing the practicals, doing the
Yeah.
project work, presenting it to the international jury panels, how that really helps in a kind of a holistic learning.
Okay. Yeah, that's another good thing about this program that it is very well balanced. Uh, there are some theory sessions and then followed by practical sessions. And those exercises, it's a very good combination of all the understanding the concepts basically. So almost everyone who is attending the programs knows about the basics. But then connecting these with the day-to-day working is very good. And especially the assignments, I agree with Rahul that these have been designed very nicely and easy to understand, and it's not that I mean you really actually enjoyed working on these assignments because they're not they give a very good outcome. So Saturday sessions were also very good when we had interactions with the I mean assignments were given to us and we had to do it ourselves. So very well planned. Let me tell you that.
Uh, Thank you very much, Sanjay. While Sanjay is here, are there any questions which the participants want to ask about the course or broader in e-buses as well?
So who all are participating? I mean, I'm not able to see. So
It's a mix of different organizations, individuals across consultant community, OEMs,
okay.
even transport planners, and some faculties, Sanjay.
So it's a good mix of team also. I mean, who is attending? So that's another good part of this program. That actually you get inputs from almost all the areas which are connected with this. I mean, all the stakeholders with the EV program. So that's another good thing about the program that we have almost OEMs, planners, everyone participating and then raising their doubts. And naturally, when you clarify those doubts, so you get a better picture of the whole thing.
Sanjay, and what difference you see, because there is so much available online around the discussions about e-buses that so, but even being coming from an OEM, being informed at that level, but how this program actually added value in you in terms of the skills that you are able to model and understand it better. Now, it's not that you are saying from someone else's experience, but you are saying because you have created your model and you know that it is working and it is close to what you were kind of earlier kind of seeing in industry. So, what is that experience, Sanjay?
See, as an OEM, normally we are very much concentrated on our own products, what we have and what we have been selling them. So we start believing that these are the best products available. But end of the day, there's a competition which is there, and we have to understand the competition. And at the same time, normally OEMs are not directly involved in the operations. So even though in these recent contract, ECC contracts, OEMs have been taking the and directly the bids, especially Tata's have been aggressive and they have taken the bids. But other OEMs have actually gone through operators. So the OEMs do not have the experience of operating the vehicles as such. Okay, especially in CNG and diesel, it never happened in the past. So only in the electric, that it was decided that since Tata's wanted to do it, I mean, we didn't have operators who could actually manage the whole show. So Tata's decided to bid, and of course, it was a learning experience when we started the operations also. So this is something this through this program actually you get to know the other side of operations, which normally is not readily available as an experience. So if you are an operator, you will like to know more about the product. So this program covers the basics as well as the operations and the challenges and the risk mitigation which is there. I mean, there are a lot of risks which are involved, and there are a lot of doubts in the mind of people who are operating it. Whether the e-buses will operate, will they be successful over a long run? What will happen after 10 years? So all these things are actually addressed in your session. So that is a good point, and especially when we talk to external people outside India who have already experienced maybe for 4 5 years. So that gives the confidence that yes, the way we are going ahead, it will be a success, and we can actually manage the whole thing very well.
Sure. Thank you again, Sanjay. And what importance to planning, Sanjay, that you think countries should really focus upon for their e-buses deployment? While yes, it is of technology, but uh, from your experience, have you seen miss of planning and the implications of it? And from this course learning, you feel more encouraged that minimum this kind of a technical planning should exist before a city or a country really want to go up for its first deployments or even its scaled up e-bus deployments.
Yes, planning is something which is missing. I agree with you, Rahul. I mean, these all our state transport undertakings and SPVs need to understand the whole thing, because this is not a one-to-one replacement of ICE buses. Suppose one route is operating, and you can't replace it directly with an electric bus. You need to understand before actually you do that. It's not that you cannot do it. There would be some challenges, and you will have to actually understand those challenges, and you should have a plan to meet those challenges. Like energy consumption on a particular route, you will have to know. You should know before actually you go for a replacement of a electric bus with the ICE bus. So this is something which every planner will have to understand. They cannot just replace existing routes with electric bus routes. This is very important, and you need to have. I mean, before you do that, you need to know whether what is the power available at those points. Do you want to have intermediate charging, or do you want to actually have a battery big enough to manage the whole day's operation? So all these actually we should know before actually we go for planning. Simply putting it in the tender that you need a e-bus for these particular routes, it will not help. And especially when the routes are so dynamic. See what is happening these days. Earlier, the routes were defined when metros were not there. Now, since metros are coming up in most of the major cities, you will actually have to redefine the routes. Once you are redefining the routes, electric vehicles, how these routes will operate on these new routes, we have to understand actually before we go for detailed plan.
Great, great. So I think this is very valuable, Sanjay. Thank you very much for your time.
Yeah.
And any categories of users or the ecosystem players, Sanjay, from all your so wide experience inside the OEMs, what kind of departments can benefit from such course? The transport planners or consultants who are designing and working with the cities for planning, and within the STU, both public or private, who are those categories of users? Because our audience is coming from all mixed understanding, like is this course really for me or not? And you specifically in role as BD and marketing in your earlier roles with OEMs, do you have any suggestion like who can really benefit from this course?
See, if you talk about OEMs, of course, all those service providers, all those who are managing the buses, actually will learn from it. Even the sales and marketing guys will also learn because there's a lot of thing beyond that selling and because this is a concept selling. It's not just a product selling. It's important in the sense that you don't learn. I mean, there's no one who teaches you all these things. Okay, and when we talk about planners and especially those who are doing the town planning and all, they for them it's also important that you understand that. See, 5 years or maybe 10 years down the, or maybe even earlier, we may have almost 100% of urban buses may be electric. That is what I feel, and I'm very confident that it will happen. So, I mean, all the things have to be planned accordingly. So we need to actually. It's very good for, I mean, planners as well. For STUs, of course, nothing better than this because STUs will have to understand one of these days they will have to operate these buses also. Right now, these are GCC contracts, but I mean, very soon we will have STUs buying these buses also once these become more popular. So, I mean, every stakeholder, starting from OEMs, planners, transporters, operators, it's a good program overall, which gives an overall view of the vehicles.
Thank you very much, Sanjay, for coming and spending and sharing your learnings. You are very valuable alumni to us.
Thanks.
So thank you. Vikrant, back to you.
Okay,
Yeah,
thank you. Can I log off?
yeah. Thank you, Sanjay.
Okay,
Sure,
okay, bye.
Sanjay. Thank you.
Bye.
So we have some questions coming in. I'll just run through the structure and then we can take all those questions. Um, so we will have three primary trainers, and then we will also have some guest faculties coming into some of the sessions and sharing their experiences in form of case studies. So Shankar Narayanan, he is a founder and CEO of Microgrid Labs, which is basically providing these solutions. He's based out of US. The company is based out of US, and they also have a web-based calculation tool for e-bus planning. So that's what I mentioned a few slides back. Once we have the understanding of how to model the e-bus fleet using Excel, you can actually scale up that model using tools like the EBOP tool. Then Rahul, you are here. You can give a quick introduction of yourself.
Sure. Thank you very much, Vikrant. Uh, uh, I'm managing director and partner at P Manifold, and since last 11 plus years, we have focused sharply on strategic energy consulting, working with national, regional, and city governments, multilaterals, PSUs, corporates, regulators, developing new roadmaps and right market development, both on demand and supply side, using right policy levers. And we have been working quite deep with multi-country governments, India being one, but Bhutan, Laos, currently working in Zimbabwe, started in Philippines, where we are looking into all different segment applications of EVs and how do we solve some of the overall technology market policy barriers and help countries to decarbonize their transportation. And in those roles, I think we have learned a lot in our interactions on all perspectives, from the product side, on the deployment sides, contractual sides between a public and a private operators, challenges that comes, and we are trying to bring all those learnings in a very applied practitioner knowledge and skills through this program. So I look forward with Vikrant being principal trainer on this program. And we have intentionally kept it short, very powerful, very hands-on through using right tools with a combination of theory and practicals and case study-based assignments and doing a project in team where you will have a diverse skill set in a team coming from various stakeholders, and that allows you to go deeper. And the jury panels that will come for your project reviews are extremely best in the industry, who are already experienced on the e-buses side, on the coming from the OEMs, coming from the operator side, coming from the multilateral side, academia side. So you will really increase your knowledge through those interactions and presentations with them. So it's a mixed program that has been designed by us. Over to you, Vikrant.
Yeah. So we have some testimonials put in here. As Rahul was explaining, a lot of people have already benefited through our previous batches. They have already benefited in their work directly in their projects and in their tasks that they are undertaking in their capacity. And this is a broad spectrum of professionals, right from consultants to supplier OEM to transport planner to again consultant to planning and optimization of EV fleets. So these are some of the specifics of registration. I think there was one question about the fee. These are the course fees. We have a special discount for students and accommodations, uh, uh, which is over the professional fees. And we also have other discount schemes. We have even scholarship offering, and we have other discount schemes which you can approach us. And if you are coming in groups, we have discount schemes for that. And then we also, as I said, have scholarship. Apart from that, I think there are a few questions. Probably take them. So, how this course can help someone like the asker, who is part of designing and manufacturing of e-drives for buses. And then they are also working on retrofit solutions for ICE buses. So this is an excellent opportunity to understand how those buses will be used. And with that understanding, selecting or sizing the e-powertrain components or e-drive components will be much more easier, and the acceptance of that product as well as the issue escalation during operations using those products will be much more easier, and the issues will be much lesser because the expectations are set properly and all the right assumptions are done during the planning. So communicating with the planners on the operation side will also be much more accurate as well as much more relevant around the problems. So that is a direct benefit that is derived. We also go through some of these sizing calculations that are done, and they would definitely benefit. We have other courses where we go deeper into the sizing elements and integration elements specific to electric vehicles, but not specific to just buses. But in more generic terms, physics-based modeling of these items in a more transient form, which will further benefit. But this is a very good and relevant start to approaching the sizing based on the application and not based on thumb rules or based on competition. Because here the scenario is everyone is learning from each other also. So it is not like there is a benchmark that is available in the industry who has got everything right. Yeah. So all the OEMs and suppliers are still understanding the usage of electric vehicles, how it is different from IC engine vehicles, and even if the usage is same, what are the challenges which are unique to electric vehicles. So those are the aspects you can benefit. Rahul, you want to add anything?
No, I think we have answered it all, Vikrant. I think the most fundamental aspect, what we call it as energy signatures, because you come from a product background, you will appreciate the most basic form is your wheel power, right? If you are able to estimate your wheel power, which is a function different from whatever is the technology you want to run any bus, but for the conditions you want to drive, this is the wheel power that you require, and then that becomes an input to your drive design, right? You want to power it through motor, then you will think through like, okay, what are the right motor specs? You want to support it with battery for providing that both power and energy requirements of motor. So you have to think about right battery pack designing with capabilities to provide both power as well as energy, right, to the motors. So all those considerations comes in. While this course, particularly eBus, will touch upon those aspects and use those tools, but you will see that we will move quickly into the other aspects of fleet planning, the charger designing, the trade-offs between opportunity versus full depot charging. So those kind of considerations on the usage, we will start go sooner. There are other programs which will stick upon more internal to the subsystems and their integrations between each other. Like one of such electric vehicle systems engineering is already an ongoing batch. But I will strongly encourage you and your colleagues within the OEMs, as Sanjay has put, no matter where you are coming from, but if you are working on e-bus space in the OEMs, on the engineering side, be it on the product development or program management side, be on the business development, marketing, sales side, this is, I would say, very kind of a strong course, a kind of a must course that will speed up your professional interactions and results and productivity on whatever you do.
Yeah. There is one question regarding if there are any discounts. So there is already a student's discount. However, as I said, you can also apply for the scholarship where you can get as much as even 100% waive of the course fee. There will be certification and examination charges, but apart from that, the course fee itself will be completely waived off. There will be few slots where you can get 50% discount as well. So please avail that. Also, one question is about whether this presentation will be available for sharing. In fact, we go better, one better, and the video of this demo session will be available soon, and we will have it circulated to all our participants in this demo session, and they can pass them on to whoever they feel are relevant and can join them in this course. So please feel free to circulate the link to that demo session video. I think we have covered most of the questions. There are a few questions, so I would encourage you to come up and ask those questions even after this demo session. We are available to speak with you and clear all your doubts, and hoping to see you all in the course. So any other concluding remarks, Rahul, before we end? We are overshot by around 8 minutes, but
No, I think thank you everyone for your time. Reach out to us for any specific questions, and the batch is starting next week as put by Vikrant. These are global batches, so you will also learn through us, but also through other participants that come for this program. So I invite you and encourage you to register ASAP in this week so that you are able to set up your learning management system and all prerequisites and everything and comfortably start working with us. So good evening, good day, and we look forward to continue our journey on growing EVs and e-buses. Thank you, everyone.
thank you all. Take care.